Good day, students. In this clip, we're going to be going over an example on the mean value theorem. This is part 2 of the two-part series. We went over the mean value theorem in the previous clip, so you can always go back there to review what the mean value theorem is. In this clip, we're just going to be going over an example. Okay. So the instructions are as follows. We're to determine if the given function satisfies the hypothesis of the mean value theorem. For B, if it does, we will have to find the equation of the tangent and secant lines to satisfy the conclusion of the MVT. And in part C, we'll generate a graph with our calculators to confirm that our results are in fact correct. All right. So in this clip, we're going to be considering the function f of x equals x to the third minus 6x on the closed interval -2 all the way to 2. Okay? All right. Now, part A, we are to determine if it satisfies the hypothesis of the mean value theorem. The hypothesis has two components. The first one is continuity on the closed interval AB, and then the second piece is differentiability on the open interval AB. Okay, so let's take a look at this function x to the third minus 6x. Can you visualize what kind of function this is? This is a cubic function, okay? So the cubic polynomials, we know what they look like. If a is positive, it's going to look something like this. If it's negative, it's going to look something like this. Based on the end behavior. So what does this two graphs tell us? Well, it tells us that this graph is smooth and continuous, all right? So there are no discontinuities of any sort on this graph. You don't have any infinite point removable discontinuities on this closed interval. And also, so that means it passes the continuity component of the hypothesis. How about differentiability? Well, we know that it's smooth, it has no corner cusps, and it has no vertical tangents also. So this function is continuous and differentiable on the open interval, so it also passes the differentiability component of the hypothesis. All right. So what are we going to say here for part A? Since f of x equals x to the third minus 6x is continuous on the closed interval -2 to 2 and differentiable on the open interval -2, 2, it satisfies the hypothesis. It satisfies the hypothesis of the mean value theorem, okay, of the mean value theorem. Okay, so since it satisfies the hypothesis of the mean value theorem, then we're going to have a C that satisfies the conclusion also. Okay, so that takes us to part B. Part B says that if the function does, we have to find the equation of the tangent and secant lines to satisfy the conclusion. All right. So in order for us to do that, we want to start by finding the C that satisfies the conclusion of the mean value theorem, and then go on from there. Okay, so let's start out by part B. Let's find the C. So to find the C, what you have to do is we have to solve an equation. We have to solve the equation f prime of C is equal to f of b minus f of a divided by b minus a. Okay? So this, the left side is the tangent line, slope of the tangent line, and then the right side is the slope of the secant line. Okay? Alright, so let's deal with the left side first, which is the slope of the tangent line. We're going to do that by finding finding f prime of c. So let's find f prime of c. So to find f prime of c, we'll start off with the original function. f of x. So f of x is equal to x to the third minus 6x. And then we have to differentiate it and then plug in c, okay? So let's find the derivative of that function. F prime of x is equal to 3x squared minus 6. Okay, so that goes the derivative. So that tells us that f prime of c is equal to what you get when you evaluate this derivative at x equals c. So you just substitute c for x here, so it becomes 3c squared minus 6. Okay, so we found the left side of the conclusion of the MVT. Now let's go to the right side and look at go over how to find the slope of the secant line. All right, so let's do that. So we want to find slope of the secant line, which is f of b minus f of a over b minus a. All right, so this is basically delta f over delta x on the closed interval from -2 to 2. All right, average rate of change. So let's go ahead and evaluate this. This is simply going to be f of the endpoint, which is 2, minus f of the beginning, -2, divided by b minus a. B is 2, and a is -2. Okay, so just note that on that interval that we have up here, the first number is a. So this right here is a, and then this one right here, that's b. Okay, just following the order of the alphabets. All right, so to evaluate this function is pretty easy. F of 2, just plug in 2 here. 2 to the third is 8 minus 6 times 2, which is 12. So 8 minus 12 is -4. And then minus, if you plug in -2 here, you get -8. And then if you plug in -2 here, you have plus 12. So -8 plus 12 is just 4. So we have -4. So that's +4 over 2 minus -2 is 2 plus 2, which is 4. All right, so here you're going to have -8 over +4 is simply -2. All right, so this is the slope of the secant line. All right, slope of the secant line. So what we're going to do is set both of them equal to each other to find the c that satisfies the conclusion of the MVT. All right, so we're going to go, so let's write an instruction for a set f prime of c equal to f of b minus f of a over b minus a. All right, so let's go ahead and do that. So set them equal to each other. We'll have 3c squared minus 6, which helps us calculate the slope of the tangent line at any value. In this case, at c, where is it equal to -2? All right, so let's go ahead and solve this resulting equation. You add 6 to both sides. You have 3c squared equals +4. Divide both sides by 3. You have c squared equals 4 over 3. And then when you take the square root of both sides, you're going to have c equals plus or minus the square root of 4 over 3, which is equal to plus or minus 2 over root 3. And then when you rationalize the denominator, you have plus or minus 2 root 3 over 3. All right, so that's the c that satisfies the conclusion of the MVT 2 root 3 plus or minus, I'm sorry, it's plus or minus 2 root 3 over 3. Okay, all right, so now we can go ahead and start writing down the equations because we have all the tools that we need. Okay, so let's start out with the equation of the secant line. Equation of the secant line. The secant line. We have only one, okay? Secant line. Equation of the secant line through let's pick this the starting point. Okay, so the starting point, where did the interval start from? The interval started from -2, right? So the slope of the equation of the secant line through -2 comma f of -2. That's what we want to find. All right, so in order to find the equation of a line, we're going to be using this formula you learned in Algebra 1, the point slope form of the equation of a line, y minus y1 equals mx minus x1. Okay, So we need y1, m, and x1 to generate our equation. So let's see what are we going to have here. Let's start with m. What is m? M is the slope of a secant line. What is the slope of the secant line? Well, we already found it. This is the value of the slope of the secant line, -2, right? So m is -2. x1 is -2 from this interval right here, from this coordinate, I'm sorry, this point right here. And then y1 is what you get when you evaluate the original function at x1. Okay, so that's going to be f of -2. Let's recall what the function is. The original function is, what was it? It's x to the third minus 6x, right? X to the third minus 6x. That's the original function. So if we evaluate this, to get y2, we're going to evaluate this function at x equals -2. So let's plug that in. So we're going to have -2 to the third minus 6 times -2. And then -2 to the third is -8 plus 12 equals 4. Alright, so that's y1. So we have m, x1, and y1, so we're ready to write the equation. So the equation of the secant line is going to be y minus y1, what is y1? 4 is equal to m, -2 times x minus x1, which is -2, so minus times minus is a plus. So there you have it, okay? If you want to plug this into your calculator, you actually have to get y isolated. You just have to add 4 to both sides so you can plug it into the calculator. Alright, so that goes the equation of your secant line. Alright, for tangent line, we know that there are 2 points that are parallel, 2 x values that are parallel to the secant line in this problem. So we're going to have 2 equations, okay? So equation of tangent line at the first c value at c equals, we know we have 2 c values, right? Do you see what they are? They are plus or minus 2 root 3 over 3. So the first one, let's do the -1 at c equals 2 root 3 over 3. So that's the first c value we're going to look at. So we're still going to use the same equation, point slope equation, y minus y1 equals m x minus x1, x minus x1. So let's go ahead and calculate what this is. So let's see here. We have x1. Now let's start with the slope first. What is the slope? What is the slope of a tangent line? Well, according to MVT, the slope of a tangent line is equal to the slope of the secant line. Okay, that's the conclusion of the MVT. So m is going to be the same as the slope of a secant line, which is -2. All right, x1 is equal to the c value, -2 root 3 over 3, and then y1, we have to evaluate the function at the c value, so f of -2 root 3 over 3. Okay, so remember what the original function was. The original function is x to the third minus 6x. So now we're just going to plug in this into that. All right, so let's go ahead and work this out. Has a lot of arithmetic in it, but it's okay. So we're going to go -2 root 3 over 3 raised to the third power minus 6 times -2 root 3 over 3. Okay, well, we expand this one right here. 3 to the third power is 8 times root 3 to the third power is 3 root 3. And then 3 to the third power at the bottom is 27 over 27. Minus, I don't want to reduce here because we have a fraction situation. So minus times minus is plus 12 root 3 over 3. Let's see, we can simplify this a little bit. 3 goes here 1, 3 goes here 9. So we're going to have 8 over 9 root 3 plus 12 root 3 over 3. Okay? To find the LCD, we need to just multiply this by 3 top and bottom. So it's going to become 8 root 3 over 9. If I times this by 3 top and bottom, it's going to be plus. I think I messed up the sign. This is supposed to be a minus right here. Keep a minus, because if you raise a negative to a third power, you preserve the negativity, okay? Alright, so negative 8 root 3 over 9 plus, we times this one by 3 top and bottom, so it's 36 root 3 over 9, right? Because the denominators has to be the same if you're combining fractions. So when you combine these two, you're going to get 28 root 3 over 9, okay? So that basically gives us all the ingredients we need to generate the equation of the line, okay? So the equation of the first tangent line is going to be y minus y1, which is 28 root 3 over 9, is equal to m, the slope of the tangent line, which happens to be the slope of the secant line, negative 2x minus x1, which is negative 2 root 3 over 3. So that is going to change to, positive 2 root 3 over 3. Alright, so that's your answer. It doesn't look pretty, but I mean, I'm gonna deal with this stuff like this sometimes. So this is the equation of your first secant line, your first tangent line, okay? Since there were two c's that satisfy the conclusion of the MVT, we have to repeat the same procedure for the second c value, alright? Alright, so let's find the equation of the second tangent line and then plug it in our calculator to see what it looks like. Equation of the second second tangent line, tangent line at, let me express this as a point this time. The c value is going to be 2 root 3 over 3, and then the y value is going to be what you get when you evaluate the function at there, okay, at 2 root 3 over 3. Alright. Okay, so let's go ahead and find the equation of a tangent line through this point with the slope that's the same as the slope of the secant line. So we're using the same equation we learned in algebra, y minus y1 equals mx minus x1, okay? So first thing we need is the slope, m. The slope is equal to the slope of the secant line, which is negative 2. x1 is the second c value, which is 2 root 3 over 3. And then y1 is what you get when you evaluate the original function as this second c value, 2 root 3 over 3. So we're basically plugging in this x value into the original function f of x equals x to the third minus 6x, okay? So let's go ahead and do that. It's going to be 2 root 3 over 3 to the third power minus 6 times 2 root 3 over 3. Alright? Alright, so we can cheat a little bit here. This is exactly the same as what we had before. The only difference is that the sign changes. So see how this one was a negative and came out to that? The one we have now, this is just going to be positive, and then this part right here will be negative. Okay, so if we want to cut corners, this is going to be, I'm just going to copy what I had before, because I don't have to do the same thing over again. It becomes 8 root 3 over 9. It's positive because this is positive this time. And then the other one was positive. This one is going to, you can call this is going to be negative. So it's going to be minus 36 root 3 over 9. Okay? You can do the steps to verify, but you end up with the same thing. All right, and then when you work this out, you end up with negative 28 root 3 over 9. Okay, so we need all the, this all the information we need to write the equation of the second tangent line. So it's going to be y minus 28. Actually, we have a minus here, so minus and a minus will make it a plus. Plus 28 root 3 over 9 equals the slope of negative 2 times x. X1 is positive this time, so we have minus 2 root 3 over 3. Okay, so that's the equation of your second tangent line. All right, so that's basically what you have to do for part B. Okay, now we're going to do the calculated confirmation. But what on earth is that? Well, all we're going to do is draw the graph with the calculators, and then draw the tangent line in the draw the secant line and the two tangent lines. If they're parallel, then we'll know that our answer is in fact correct. If we see some uh, intersections here or some lines that are not parallel or skew lines, then we know that our results are not correct. Okay, so start from home. I'm using the TI-89 titanium here to do the graph. So what we're going to do first is enter the original function. Okay, let's see what was the original function. There goes the original function. Okay, so I'm going to enter the original function first. X to the third minus 6x. Enter. And then now let's enter the equation of the secant line. Equation of the secant line is negative 2 parentheses x plus 2. What happened here? X plus 2. Now, you notice this minus 4? This is y by itself. So if y is by itself, then that means I need to toss this minus 4 over here. Move it to the right side of the equation. Okay, if I move it to the right side of the equation, it becomes plus 4. In order to enter equations into your graphing menu on the TI-89s, your functions have to be explicit, okay, in terms of y. So this is what the calculator understands. So don't forget to switch that sign. All right, so let's enter the equation of our two tangent lines. So the first one is negative 2 times x plus 2 root 3 divided by 3, close the parentheses, and then this number gets moved to the other side, so the sign changes to plus 28 root 3, 28 root 3 divided by 9. Enter. Alright, so anytime you enter a complicated expression into the TI-89, it has a pretty print display system where you can easily check your entry to make sure it's consistent with the original problem or what you had intended to enter. So if you look here, let's make sure that this is exactly what we want. Negative 2x plus 2 root 3 over 3 plus 28 root 3 over 9. Excellent, that's what we want, okay? All right, let's enter the last one. The last one is going to be negative 2 parentheses x minus 2 root, my root keeps changing, 2 root 3 over 3, close the parentheses, and then this number gets tossed to the other side, so the sign changes to minus 28 root 3 divided by 9. Enter. Okay. All right, so we just graph it, keep our fingers crossed, hopefully it comes out how we want. Let me make this a little bit bigger. So to graph, you just hit diamond F3. All right, so there goes the function. And then the secant line. And then, let's wait for a second, it's kind of slow. The first tangent line. And second tangent line. It's really slow, but yeah. Anyway, so that's that. We can see that our answer is in fact correct. Okay? Alright, so I basically generated the same graph using a computer program here. So let's see what it looks like. This is the function. I kind of restricted the function to the indicated domain from negative 2 to 2. This is the secant line right here. You see the line through the endpoints. Okay? And then the first tangent line, there goes the first tangent line. That's the C1, the negative 1, negative 2, something. I don't remember. Anyway, there goes the first tangent line, and then there goes the second tangent line. And if you look at the slopes, you can clearly see that three of them are parallel. Okay? And then that shows that our answer is in fact correct. All right, so lastly, all you just have to do now is basically sketch the graph, a rough sketch of the graph on your in your notebooks using the from what you got from the calculator, and then label what everything signifies. Okay, so this the black line right here, that's f of x. The original function equals x to the third minus 6x on the domain negative 2 to 2. All right. And then this blue line right here is the first tangent line, which is, let's see, this is this first tangent line is given by y minus 2 root 3 over 9 equals negative 2 times x plus 2 root 3 over 3. Okay? And then this is the C1 value. Let's indicate where the C1 value is. If you trace it vertically downwards, this point of intersection right here, it's traced downwards right here. It's going to be like 1.15, something like that. So there goes this first C value, it's C1. Okay. And then this red line right here is the second tangent line. Okay, this is y, scroll down a little bit, y minus 2 root 3 over 9 is equal to, actually this one is plus, y plus 2 root 3 over 9 is equal to negative 2 times x minus 2 root 3 over 3. Okay, so this is tangent, tangent, and then this is also tangent. What are we missing here? We're missing the secant. Okay, so this one right here, this is the secant line. Okay, secant, and it has the prettiest equation out of the bunch. So it's y minus 4 is equal to negative 2 times x plus 2. All right, and then I need to indicate where my second C, my C2 is, the second value of C that satisfies the conclusion of the MBT, and it's right here at this intersection. So just trace it downwards right here. It's kind of symmetric as you can see. So that is the C2, the second value of C that satisfies the conclusion of the MBT. All right, so that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here so you can get updates to other cool clips such as this. And please post a comment to let me know what you think about this presentation. And do give me a thumbs up if you like this clip. I appreciate it. More clips coming from math.serve.com. Thanks again for watching and have a wonderful day.